So the main result is that every incentive-compatible mechanism is payoff equivalent to a mechanism that is ternary in every stage. So the implication of this result include the principle can restrict attention to only using ternary mechanisms, and all the optimal mechanisms given any welfare function must be ternary in every stage. So this paper is mostly related to the literature on dynamic mechanism design without transfers. So there are papers where the model allows good to be allocated in multiple periods, or the good is allocated to one of the agents. In my paper, the good is allocated only once, and it's a public allocation. So in their papers, most of them focus on a class of virtual budget mechanisms, for example, token mechanisms, where the agents are given tokens and they can spend a token when they really need the allocation. So here, it's more or less the same, in the sense that every time an agent vetoes, the continuation payoff will decrease, so that in the future periods her veto power will decrease. So it's like a virtual budget of veto powers. So if someone uses veto power too much, then at the end the mechanism will use the dictator mechanism, so that that agent will not be allowed to veto anymore. So there are other papers that works on very similar committee search problem, but in most of their paper, they restrict the decision rules to be either unanimity rule or the majority voting rule. So both unanimity and majority voting rule are special cases of ternary mechanisms, but in their papers, they are able to solve the exact thresholds for the optimal or the stationary unanimity rule or majority rules. In my paper, I cannot solve for the thresholds for the optimal ones. I am just able to categorize all implementable mechanisms. So some possible extensions include extension to multiple agents. In my paper, I focus on two-agent problem. So the mechanisms on the Pareto optimal boundary for the multiple agent case, I can show that they are still ternary. But the problem is on the non-Pareto optimal boundary, it's not clear whether they can be constructed from ternary mechanisms or not. So in the proof, the way I show that the non-Pareto optimal boundaries are consist of ternary mechanism by fixing the payoff for one agent and decrease the payoff for everyone else. But that will not cover everything on a non-Pareto optimal boundary in the multidimensional case. So I may need other specific ternary mechanisms to show that everything on the non-Pareto optimal boundary are still randomizations among ternary mechanisms, but I cannot show that at this moment. Another possible extension is extending to allow random mechanisms. So right now, we only allow quasi-deterministic mechanisms, and I can show that any random mechanism can be decomposed into deterministic ones, but the problem is that it's not clear that any random incentive-compatible mechanism can be decomposed into deterministic incentive-compatible mechanisms. So if I can show that, then given any random mechanism that's incentive-compatible, I can first decompose into deterministic ones, and then they are payoff equivalent to the ternary ones. Therefore, all the random ones will be payoff equivalent to the ternary ones as well. So right now, I'm not sure this is true. I suspect it's decomposed. This decomposability can be shown as well, but right now I have no idea how to do that.